Hello all. In this particular lecture, I'll be talking about some of the important terms that we have already seen in our last classes. Okay. So the first of all, we will see what is an item set. So let's go back to this particular slide that we have seen. All right. So what is an item set? Right. For that, we have to look at this data set. I told you that a collection of data, okay, which is given in the tabular format like this is known as your data set. So here you'll have transaction ID, the number of transaction here, and what are the items in each transaction. All right. Now when we talk about a group of items, it is called item set. So item set may be a single item or maybe a collection of items, and each of these are your transaction IDs. All right. And then when we talk about item set, we also talk about the size of the item set. How many items are there in each item set? That is given by the value k. Okay. And next is, which are the item sets which are frequent? So what are the item sets which are frequent? We see that for each item set, there is a support value, support count or frequency count. Okay, so when the frequency count is higher than the given minimum support value or threshold, then we can say that those items are frequently occurring in that item set, or that item set can be considered as frequent item set. Okay, that item set is frequently occurring. So this we have seen in our last class. So we'll just relook at it. The definition of k item set. A set of items is referred to as an item set. Okay, so it can be one single item or it can be more than one item, 2 or 3 items. Okay, an item set that contains k item is a k item set. K gives the number of items. The set of computer and antivirus software. So how many? 2. 1 and 2 is a 2 item set. Now next term, very important term, is occurrence frequency. With every item, there is a value which is called occurrence frequency, is the number of transaction that contains the item set. How many times that combination, that number of items in the item set has occurred, it gives the frequency of that item set. Okay, the count. So it is also known as frequency, support count. We have seen how to calculate support count, or simply we can say the count of the item set. So in other words, how many times this particular combination, that is computer antivirus, has occurred in different transaction. Okay, that is the occurrence frequency. Next, we were talking about support and confidence. Okay, so we'll see what is relative support here. The item set support defined in previously sometimes referred to as relative support. Okay, support we have seen occurrence frequency divided by number of transaction. Okay, so it is also sometimes referred to as relative support. Okay, so if you divide it by number of transaction, it is called relative support. And if you don't divide it, just take the numerator, that means how many times it has occurred. If you just take that, in that case it is called absolute support. This we have seen. Okay, when you don't divide, it is absolute, but when we divide with the total number of transactions, that means you're actually comparing it with the total number, then it's called relative support. Okay, so if the relative support of an item set, if after calculating relative support, you find that that value, okay, satisfied a pre-specified minimum support, okay, is higher than or equal to a given minimum support value, then we can say that it is a frequent item set. Okay, item set I satisfied a pre-specified minimum support threshold, then I can be termed as a frequent item set. Okay, the set of frequent k item sets is commonly denoted by LK. Okay, which means frequently occurring k item set. Okay, so some item sets are frequent and some item sets are not frequent. Frequent are those in which the support is higher than the minimum support. Okay, so these are important terms. Then we know that after finding your support and confidence, we have to find the association and correlation and thus form rules. Okay, whether the different items can be combined, associated or not. Okay, so that is termed as association rule mining. So after you have found support and confidence, then we decide whether that rule can be mined or it cannot be mined. Okay, association rule mining, and it can be viewed as a two-step process. Okay, now we have seen these processes. Now we'll just try to put it in two different steps. First of all, given a data set, we have to find all frequent item sets. We have to see how many item sets are there. Okay, what are those frequently occurring patterns? Okay, frequent item sets. So by definition, each of these item set will occur at least as frequently as a predetermined minimum support min sub. So we'll look at those item sets which are frequent, and we know that those item sets are frequent in which the support is higher than or equal to min sub, that is minimum support. So that is our first task, first step. After you have done that, then step 2, okay, then we have to associate it, then we have to find the rules. So generate strong association rule from the frequent item set. Now we find frequent item set, there's no doubt, but it doesn't mean that all frequent item set will lead to association rules. Okay, then we have to check which rules, which item sets can be strong or weak. Okay, in last class I was talking to you about interestingness. Okay, interestingness of association rules. So we have to find which rules are interesting and which rules are not, depending on support and confidence value. Okay, so that we will apply in step number 2. Whichever frequent item sets are there, we will find the support and the confidence, and then we'll decide yes, that it can be formed as an association rule or it cannot. Okay, or we disqualify it. All right, so generate strong association rule from the frequent item set. By definition, these rules, and how do we know that these rules are interesting, strong? They should satisfy minimum support and minimum confidence. Okay, just as we discussed. So these two steps are the two-step process which we will inculcate in association rule mining. All right. So very important term here again. Okay, we'll have another important term here, frequent set. Okay, which set are called frequent set? So we'll have a standard definition here. Let's try to see that. Let T be the transaction database and min sub is a user specified minimum support. An item set X, item set is a part of that item, okay, of which belongs to the data set. Okay, it's a part of, it's a subset. This is symbol for subset. A is said to be frequent. A part of that subset, a subset of A is said to be frequent. Okay, a part item set is said to be frequent in T, in that transaction database. Okay, in the data set that you have seen, with respect to minimum sub, and min sub is given to us. It's already user specified. When is an item set considered to be frequent? Okay, item set X is considered to be frequent when, see, it leads to the same thing, when support of that item set X is what? Item set in the transaction database. After you have calculated support, if that support is greater than or equal to min sub, then we say that that item set is a frequent set or frequent item set. Exactly like the way we have discussed, but here it is like mathematically put. Okay, in the terms, it's like we use a symbol subset and then greater than equal to min sub. Okay, so if support is greater than equal to min sub, then that T, that item set, okay, or the in T means transaction database set, X is the item set, then that item set X is considered to be a frequent set. And two more extra important things are there about this frequent item set. It exhibits some interesting properties. Number 1 is downward closure property. Any subset, if you further break it, now X is like some items. If you further break, let's say it's a 3 item set. K item set is here 3 item set. Okay, so if you take any subset out of that 3 item set, you take two out of it. Okay, and if that 2 item you're taking from a frequent item set, it also has to be a frequent set. That is what downward closure properties. Any subset, if you break that item set, then the component, that is the subset, is also a frequent set. So out of 3, if you're just taking 2, even that 2 has to be a frequent set. So that is called downward closure property. Similarly, the next property is upward closure. Any superset of an infrequent item set is an infrequent set. Now this is just the opposite. Okay, if you break frequent item set, the small pieces are also frequent. And if you join infrequent item set, okay, it will still remain infrequent. You cannot change it by increasing the size. If the small component is infrequent, no matter how many items, more items you add, it will still remain infrequent. So that is other interesting properties of frequent item set. Okay. Then another very important term is when is a frequent item set called a closed item set. Okay, sometimes a frequent item set is called closed. Again, let's see, that is also simple. It is a frequent item set, no doubt it is a frequent item set that is both closed and its support is greater than or equal to min sub. Okay, that we know. So it has to be frequent, meaning that support is greater than or equal to min sub. Okay, and it has to be closed. Now when do we call it closed? An item set is closed in a data set if there exists, now listen to this very carefully, if there exists no superset higher set than that has the same support count as this original item set. Now frequent set is called closed item set if after adding some more items to it, okay, you will not get any higher item set which is having higher, which is having that has the same support count, okay, higher support count. That means the one that you are having is the highest. If after adding more items you are not getting the same support count, okay, so this is the maximum that you can go. If you add something, then either the support count will go down, okay, so this is the highest that you can achieve. If you add something extra, if you try to add something extra, that means if you have tried to make it a superset, then you will see the count is no longer the same, it rather goes down. So in that case it is called closed frequent item set. Okay, so when do we say that frequent item set is closed? When, okay, if there exists no superset, that means if you add some more items that has the same support count as this, the component original item set. Okay, so this is the highest. If you add, then it will no longer remain highest. So in that case it's called closed frequent item set. And how do we identify? First, identify all frequent items. Now how to see which frequent item sets are closed? Okay, so first of all you identify which are the item sets which are all frequent. So you'll see all the item sets higher than the min sub, you put it in one side. Those are your frequent item sets. Now what happens? Then from this group you have to now see which are closed. Okay, so from this group of frequent item sets, find those that are closed by checking to see if there exists a superset, something higher than that has the same support as the frequent item set. If you see that there is some superset in which support is either same or high, then you cannot say that this is closed. Then you say that okay, this item is not closed, it is disqualified. But if you see that there's no superset having the same super count, okay, support count, then you say okay, fine, this item set is closed because nothing higher than that has the same support count. All right, so that is how you identify frequent item sets which are closed. Nothing above it has the same super count. So just have a look at this example. All right, and this will be our last topic here. So here these are your A, B, C, D, and then we have the superset. Okay, A is joined with another component, A, B, A, C. You can see B is joined with all these lines are the superset. That means we have added components. So these are the arrows. And C, you can see C is this AC, then BC, then CD, and D is like this 3, AD, BD, and CD. So here are the items, and here we have the superset. Okay, now here which are the closed ones? All right, and on the top they have given the count. Okay, support count. These numbers are your support count. Now AD, look at AD. Where is AD? AD is a frequent item set. Okay, frequent item set, but we don't know whether it is closed or not. So in order to check whether it is closed or not, we have to see the supersets. Superset means after adding higher sets. Higher means when you add more items to it. So more items means this. Okay, this is one, this is another. Okay, so these are the supersets of AD. And if you look carefully, you have to focus on the count. This is okay, this is less, so it can be closed. But when you look at this particular superset, we see that the count is same, which is not the definition of closed. Okay, it has to be less. Okay, it cannot be same or greater, but here you see that the superset is greater. Okay, so that is why AD is frequent, but you cannot call it closed frequent because it has a superset which is having the same super count. So that is why AD is a frequent item set but has the same support as ABD superset. So it is not a closed frequent. So this is one example of a not a closed frequent set. Okay. There are others also. You can see AC also same. So it is not. ACD also it's not. Okay. So AC is not a closed frequent set. Okay. Whereas now let's try to find out where is the closed one. All right. So concentrate on C. Okay. C is having count 3 and then check all the supersets. Okay. So this is AC. It is 1 less. Okay, fine. Can be a closed item set because superset is having lesser count. Similarly, the next superset is BC. Okay, less. Okay, fine. But you look at the CD. This one is also less. So here what happens? This is a frequent item sets whose supersets are not having the same count, support count. Okay, they are having less count, less super count, which is what the closed frequent items set definition says. Okay, it has to be less, it cannot be same, and that is true for C. And that is why C, on the other hand, is a closed frequent item set. Why? Because all of its supersets, see this AC, BC, CD, have support count that are less than the count of C. This is 3. Okay, you have 1, 1, 2, all less. So this is how you will define closed frequent item sets. Okay, now this is very, very important. All right. Thank you, class.